Section 2.6 is on page 140, talks about double angles and the half angle formulas. We're really going to focus on the double angles and all the formulas that we're going to get out of it, or identities. I'm going to start off with the sine of twice theta. I could say that's the sine of theta plus theta. And we know when we add two angles, that will be sine of the first, cosine of the second, plus sine of the second, but it's the same thing, cosine of the first. And since those are exactly the same, that would be twice the sine of theta, cosine of theta. So that's our first identity. Sine turns out to be a nice identity. And if I try to do the same with cosine, I would say cosine of theta is cosine of twice theta. Oh boy. Cosine of twice theta would be the cosine of theta plus theta. That is the cosine of the first, cosine of the second, minus sine of the first, sine of the second. And that turns out to be the cosine squared of theta minus sine squared of theta, which in turn could mean 1 minus sine squared of theta, because that's what cosine squared equal from the Pythagorean identity, minus sine squared of theta, and that will become 1 minus twice the sine squared of theta, or that could be the cosine squared of theta minus, and I could say, but sine squared can be replaced by 1 minus the cosine squared of theta, so that will be the cosine squared of theta minus 1 plus the cosine squared of theta, which is twice the cosine squared of theta minus 1. So when I come in and say cosine of 2 theta, that has one of three identities. It's either the cosine squared of theta minus sine squared of theta, or it is 1 minus twice the sine squared of theta, or it is twice the cosine squared of theta minus 1. So sine has only one identity. The sine of the double of an angle is 2 times the sine of that angle, cosine of that angle. But cosine will have 3 of those, and from there, if I take this middle identity, if I take this, and I go on the side, and I say, well, look, this is the cosine of 2 theta, and that is 1 minus twice the sine squared of theta. If I swap those, that would be twice the sine squared of theta equal 1 minus the cosine of 2 theta. And if I divide by 2, I could say the sine squared of theta is 1 minus the cosine of 2 theta divided by 2. Also, I could come in and take this identity and say, well, look, cosine of 2 theta is actually twice the cosine squared of theta minus 1. If I solve for cosine squared by moving the 1 over, and if I divide by 2, I could say the cosine squared theta is 1 plus the cosine of 2 theta divided by 2. Those would be the power reduction identities. I'm going to sum everything up in a minute. Now, if I take this identity, since I am here, so that's done. The half angles we're not going to focus on as much really. So if I take this identity and say, look, the cosine squared of theta is 1 plus the cosine of twice theta divided by 2. And if I square root both sides, I'll get a plus or minus the square root of 1 plus the cosine of 2 theta divided by 2. And I notice that this angle here is double that angle. So if I went in and made that cosine of theta over 2 plus or minus the square root of 1 plus the cosine, we just agreed that this is double that. If you double theta over 2, you will get theta. And similarly, if I take this identity and say sine squared of theta is 1 minus the cosine of theta divided by 2 theta divided by 2. Again, I notice that this here is double that angle. So if I square root both sides, that will be 1 minus the cosine of 2 theta divided by 2. And if I say then, let's go the sine and make that a beta, that will be plus or minus the square root of 1 minus the cosine of divided by 2. So if I make this over 2, we agreed that this is double that. So whatever this is, this will be 2 times, which is beta. Those would be the half angles. And that's all the identities we have. Now let me summarize what we just did. We have just established that the sine of twice an angle is 2 times the sine of theta cosine of theta. We know that cosine of 2 theta happens to have one of 3 identities. We established that the sine squared equal 1 plus minus the cosine of 2 theta divided by 2, and cosine squared is 1 plus the cosine squared of 2 theta divided by 2. That's called power reduction. Those two are a must for calculus. Half angle, we just take the square root of both sides and replace this by this angle, and we know this is double that. But those we're not going to focus on for my class. Your teacher, if somebody else is watching this from another class, your teacher might be talking about those. I don't see them in calculus, that's why I don't teach them anymore. But not that they're not important, they just don't come up. And we have more than enough on our plate than to just spend time on those. So, you notice I didn't talk about tangent. I provide tangent on the exam if I was to ask you about it. If I don't, then you're not going to see it. But sine and cosine, you need to remember the double angles and the power reduction. So now you notice that we are repeating a lot of what we did before. If they gave us on number 10, this is on page, what page is that on? That's on page 147 in our book. I am going to work out a sine of half angle just in case you need it. So if I want to know what the sine of 2 theta is, that is twice the sine of theta cosine of theta. So I need to know what the sine is, the cosine is, and pretty much that's it. Well, this is kind of repetition. I know cosine is adjacent over hypotenuse, but I don't know which quadrant I'm in. In this case, they pretty much handed it to me. They told me, well, hey, the angle has to be between 0 and pi over 2, indicating that the triangle is in quadrant 1. I could use identities. I don't recommend that. This triangle is a lot more efficient. The height adjacent over the hypotenuse. We know in this quadrant y is positive, and that becomes a 4. And all what I need out of that triangle is the sine and the cosine. Sine of that angle would be the opposite over the hypotenuse, and cosine would be the adjacent over the hypotenuse, and there it is. If I look for the cosine, well, I have 3 identities. Any one of those will do. I could say that is the cosine squared of theta minus sine squared of theta. That's fine, that'll work. What does cosine equal? What does sine equal? Cosine is the adjacent over the hypotenuse, and sine is the opposite over the hypotenuse, and there it is. If you use 1 minus twice the sine squared of theta, that will work. And if you use 1 twice cosine of theta squared minus 1, that will work. Now the half angle, I'm going to do it. Again, you're not responsible to do it on the homework. All what you have to do on the homework is A and B. So this is really plus or minus 1 minus the cosine of theta divided by 2. And that's really plus or minus the square root of 1 minus cosine is the adjacent over the hypotenuse. There you go. Now, the tough part of this is always, is it plus or minus? And this is where you have to come in and adjust. To make that theta over 2, you multiply it by a half. But whatever you multiply one of those, you must multiply the other. So, I'm sorry, I went to the wrong one. Not that. I meant this angle. If I want theta over 2, I multiply this by a half. And that would mean theta over 2 is between 0 and pi over 4, which indicates this is in quadrant 1, and in quadrant 1 we know that sine is positive. Again, I'm not going to do any more half angles. I'm just going to focus on the double angles and the power reductions. And again, I'm trying to find the sine of 2 theta and the cosine of 2 theta in the same problem. So if I look at number 20, it says the cotangent of theta equals 3 over 1. Well, cotangent and tangent, I know they're positive in quadrant 1 and 3. And then they say that cosine of theta is negative. That indicates that the angle must be in quadrant 3. There's theta, opposite over adjacent, but I know both of those are negative in this quadrant. And to find the hypotenuse, h squared equals negative 3 squared plus a negative 1 squared. H squared equals 9 plus 1, which is 10. And the hypotenuse would be the square root of 10. And the reason it doesn't pick up plus or minus, if you remember, because this really represents the radius of a circle. So when I look for part A, sine of 2 theta is twice the sine of theta cosine of theta. That would be twice. And once I get the triangle, pretty much everything's straightforward. I need the sine. The sine is the opposite over the hypotenuse. And the cosine is the adjacent over the hypotenuse. There it is. And for the cosine, last time we used cosine squared minus sine squared. Let's say you're going to use twice the cosine squared of theta minus 1. That will work. If you evaluate those, you get the same value no matter what. And here I only need the cosine. That would be the adjacent over the hypotenuse. And there it is. The next set of problems. So first set deals with what we just did. Find the sine of 2 theta, cosine of 2 theta, given one of those. Go to the triangle and you're in good shape. Second set is identities. And again, you get better at those by doing enough of them. I glance at this. I notice this is cosine. I know it's one of 3 things, but that's simple enough. This looks as a more complex. So I start with the more complex side. And I know since there are no squares, I'm going to write everything in terms of sine and cosine and simplify. And most likely that's all it takes. So cotan and tan. That's the cosine of theta over sine of theta plus the sine of theta over cosine of theta. And it's a complex fraction. Back from the days, we're going to find the LCD for the top and bottom. And then make sure they all have it. LCD would be the sine of theta cosine of theta. This is missing a cosine. Multiply top and bottom by it. This is missing a sine. Top and bottom by it. This is missing a cosine. Almost the same. And this is missing a sine. And if they all have the same denominator, when we multiply by the reciprocal, those under each other, I'm left with the cosine squared of theta minus sine squared of theta over the cosine squared of theta plus sine squared of theta. And I know that cosine squared plus sine squared is a 1. And look at that. Cosine squared of theta minus sine squared of theta. Isn't that the cosine of 2 theta? And there it is. Remember, you're only allowed to work with one side of the equation. You can't work with both sides. I'm gonna finish this up in the next video.